All right, let's get started with 5.4. So in 5.4, we're going to add a couple of formulas to our identities sheet. So if you have that, you're going to want to pull those out of your notes and add on the following formulas. So we want to be able to have formulas when we add or subtract different angles and then find the sine, cosine, or tangent of them. All right. So for instance, if we had the sine of 30 plus a different angle, maybe 60, we would be able to plug 30 in for u and 60 in for v all the way across into whatever formula we're working on. So pause this if you need to, take a second, make sure you have the sum and difference formulas added into your identity notes, whatever you got going. Should have that one piece of paper with all of our formulas from chapter 5 going so far. Alright, so let's try some of these formulas. I've got it printed small right here. We're going to do the exact value of pi over 12. So, probably easier if we think about this instead of pi over 12 in radians, if we thought instead about this in degrees. So, if we make pi over 12 degrees, we'll go 180 over pi. That cancels. 180 divided by 12 is 15 degrees. So now the question is, how do we get sine of 15 degrees? And we want an exact value. So we can't just plug this into our calculator and get the decimal approximation. We need the exact value, which means we need to use some numbers from our unit circle. All right, so let's remember some angles on our unit circle. We've got 0, we've got 30, we've got 45, we've got 60, we've got 90, and we could keep going into quadrant 2, but those are actually enough to figure out 15, because we're going to look at that list and say, are there any two of these numbers that if we either added or subtract, we would get 15, and we can use 30 and 45. So the sine of 15 is the same thing as saying the sine of 45 minus 30, and then we can go ahead and use this formula, the sine of u minus v. So the sine of u times the cosine of v minus this cosine of u and the sine of v. Alright, so we're just plugging in the correct angles in there, and then we go to our chart, or we can look on the unit circle and say, alright, what's the sine of 45? That's root 2 over 2. What's the cosine of 30? That's root 3 over 2. Minus, what's the cosine of 45? Root 2 over 2. And what's the sine of 30? 1/2. We're going to simplify this and get root 6 over 4, right? 2 times 3 is 6, minus root 2 over 4. And so our final answer then is root 6 minus root 2 all over 4. And be careful here, you cannot put the root 6 and the root 2 together. Those are not like terms. That's your answer. Root 6 minus root 2 all over 4. All right? So, very similar steps. See if you can figure out number 7. Try A and B. All right? And it might help to turn these, nope, those are already set up for you. Don't need to turn them into degrees. I think you can do it in radians. So give those a shot. All right, let's talk about 75. So the last example we did was subtraction. This one we could do addition, because we take our angles we know, 30 plus 45 gives us 75. So we're just going to use 30 for our u and 45 for our v. So we're going to be using this formula. So we'll say cos u, cos v. And in the cosine formulas, if it's a plus, we'll subtract. If it's a minus, we'll add. It's the opposite. So we're going to minus sine 30, sine 45. And so we'll end up with root 3 over 2, root 2 over 2, minus 1/2, root 2 over 2, for a final answer of root 6 minus root 2 all over 4. All right, so you'll start to get some similar numbers. And notice here, we did sine of 15, and then we did cosine of 75, and we got the same answer. This is the cosine of 75. It's also the sine of 15. Notice that 15 plus 75 add up to 90. They're complementary. So remember, complementary angles, the cosine of one is the same as the sine of the other, always, right? That's the formula we have. Cosine of 90 minus the angle is equal to the sine of the angle that we have in our formula sheet. All right? Now, quick note on this one. This is in the book. You could have also come up with 75 by doing 120 minus 45. 120 and 45 are both angles on our unit circle. So there's multiple ways to do these problems. No one right way, but the answer will always be the same if you do these correctly. Give number 11 a shot. Oh, and the answer's already up there. Make it go away. Hold on, let me pause this. You didn't see anything. And I'll give you a second so you don't see it. All right, there you go. Try 11. And when you're ready, press play again, and the answer will show up. All right, example 3. So now, in example 3, we're going to try to find the sine of angles u plus v, but we're not actually going to be given those angles. We're just going to know things about them. So we're going to be told that the sine of u is 4 over 5, and we're going to be in quadrant 1. That's what this is saying. We're between 0 and 90 degrees, so quadrant 1. So here's what we're going to do. We're going to draw an angle, a triangle in quadrant 1. We're going to label it u, that's our angle, and we know that sine is opposite over hypotenuse, so we have 4 over 5. Knowing that, we know that's a 3, right? 3, 4, 5 right triangle from the Pythagorean. All right, this is 90 to 180, so this is quadrant 2. So in quadrant 2, we're going to draw ourselves angle V. And then the cosine is adjacent over hypotenuse, and this is a 5, 12, 13 right triangle. 5, 12, 13 Pythagorean triple. You can also use the Pythagorean triangle to get that. All right, so now we got to do sine of u plus v. So this is our formula. Sine of u, cosine v, plus cosine u, sine v. So let's go to our triangles and pull these out. All right, sine of u is 4 over 5. We know that. That was given. We didn't need the triangle for that. Cosine of v, we all know that. That was given to us as well, negative 12 over 13. But now the second part, we need to use our triangles. The cosine of u is 3 over 5. So we look at the u triangle, and we do the cosine. For v, we're going to look at the v triangle and do the sine. The sine is 5 over 13. All right, so let's simplify and get ourselves an answer. 4 times 12 is negative 48, and 5 times 13 is 65, plus 15 over 65. So our final answer here is negative 33 65ths. All right, so walk through those steps, make sure you understand them, and then give 43 a shot. Okay, all right, so similar work here on example 4. We're going to use what we know about arctan. And arctan with a regular cos or sine means draw a triangle. But let's write the formula out first. This is a cos of u plus v. So this is going to be cos arctan, and just for space I'm going to use the tan negative 1 of 1 cos inverse cos of x. Right, so we've got these two parts, minus sine of u, sine of arctan 1, sine of v, which is going to be arccos of x. All right, so let's draw these things here. So if we have arctan 1, I'm going to draw it over here. If this is my angle, u, and the tangent is 1, that means that the opposite over the adjacent is 1 over 1. That makes the hypotenuse root 2. And I want a triangle for V. And in V, it's arccos. So, adjacent over hypotenuse. And then that makes this 1 squared minus x squared, or just 1 minus x squared. From the Pythagorean theorem, we're getting that. All right, so let's plug this in then. The sine of tan of negative 1, that's the u triangle. So I'm looking at u and getting the sine, and the sine here is 1 over root 2, or root 2 over 2. Oops, sorry. I skipped the cos. I apologize. We'll get back to that in a second. Cos of tan. So we're looking at this one. The cos is 1 over root 2, which is root 2 over 2. All right, nice thing here. Cos and inverse cos going to cancel out. We're left with x. And then we know that the sine of this one is 1 over root 2, or root 2 over 2. And then sine of, this is our v, so we look over to our v triangle and get the sine. We have root 1 minus x squared all over 1. And so our final answer here is going to be root 2x minus, and we could distribute the 2 in here, 2 minus 2x squared all over 2. All right, so not the prettiest answer, lots of variables, lots of things going on, but the key here is, again, draw yourself a triangle for u, draw yourself a triangle for v if you see the arc going on. All right, so this might be one of the trickier ones, but give 57 a shot, okay, and then walk through the solution once you get an answer. All right, so now we have this cofunction identity. This is in our notes, and we're just accepting it up to now, but now we're going to prove it. So we're going to use our sum and difference formulas to prove it. So this is a cos minus. This is our u, this is our v. Let's plug it in and see if we can simplify down to sine x. That's our job. So cos u, cos v, plus sine u, sine v. All right, pi over 2, well, that's 90 degrees. That's right here. What is the cosine there? What's the x value? That's a 0. Plus the sine value here. The sine value is the y value. That's a 1. 0 times cosine. Get out of here. We're left with just 1 sine x, or sine x. And that's what we were trying to solve. So our job here is done. We've proved the identity to be true. All right? So 61, prove this identity is true. Go the other way with it. All right, so now we're going to derive some reduction formulas on this one. And so I'm just going to jump in there and do these, simplify each expression. All right, so sorry, a reduction formula here is when we add a 90 degrees or a 180 degrees or a 270 degrees, any multiple of 90 degrees. All right, so this one is saying let's add 3 pi over 2. Okay, we're adding multiples of pi over 2. And let's see what we get. So we're using the cosine minus the difference, cosine difference formula. So we've got cosine u, cosine v, plus sine u, sine v. All right, 3 pi over 2 is down here. The cosine there is 0. Sorry, backwards. Cosine theta times 0 plus sine theta. And down here, the sine value is -1. That'll go away. We're left with negative sine theta. And we'll do b. All right, so first time we've used a tangent function here. So this is our u and this is our v. So we're going to have to use this formula. So we've got tangent u plus tangent v all over 1 minus, and then we multiply them together. All right, so when we're down here, 3 pi over 2, remember this is 0, comma 1, and tangent is y, sorry, 0, negative 1, over x, okay? Definitely cannot do that. Oh, I'm going too fast, aren't I? It's not 3 pi over 2, it's just 3 pi. That will make it much more doable. Let's change that. So, 3 pi, where is that? Not on our unit circle, but we can always add or subtract 2 pi. So 3 pi, take away a 2 pi, we've left with just pi, and that's right here. So that point right there is negative 1 comma 0. The tangent of that is 0 over negative 1, or just 0. So this will simplify to be tan theta plus 0 all over 1 minus tan theta times 0, or just 0. And so we're going to have zeros don't matter, tan theta over 1, just tan theta. That would be our answer there. Alright, so keep track of all your identities and see if you can simplify sine of 3 pi over 2 plus theta. Alright, 2 to go here. Example 7. Let's find all the solutions of this in the interval 0 to 2 pi. So, one trip around the circle, around the unit circle here, just the first trip from 0 to 2 pi. Alright, so let's simplify this. Sine of x plus pi over 4, and remember pi over 4 is right here, root 2 over 2, comma root 2 over 2, for reference here in a second. So sine x cos pi over 4 minus cos x sine pi over 4. Alright, so that's the first one. We've done this one. And then plus, we'll do it again. Sine, this is our new u and our new v. Sine of x cosine pi over 4. And it's a minus function, so again we're going to subtract minus cos x sine pi over 4. Let's clean it up. Sine x cosine pi over 4 is root 2 over 2 minus root 2 over 2 cos x plus root 2 over 2 sine x minus root 2 over 2 cos x. And so now we've got root 2 over 2 plus root 2 over 2 is 2 root 2 over 2 sine x minus root 2 over 2, sorry, 2 of them, 2 root 2 over 2 cosine x. Oh, hold on one second. Alright, sorry about that. I knew this didn't look right. I put the wrong sign down there. This should be a plus. So this is a plus here. So the cosines are going to cancel each other out. One's a plus, one's a minus. So we're left with 2 root 2 over 2, which is just root 2 sine x. And then all the way back here from the beginning equaled 1. So we still had that. Let's divide both sides by root 2. We've got sine x equals 1 over root 2, which is root 2 over 2. And there was a negative in front of this. Okay. All right, so we want to get x by itself. Let's do the inverse. X equals inverse sine of root 2 over 2 negative All right, on the unit circle, we need to find all the angles where the y value is negative root 2 over 2, and there are two of them. They're the 45-degree angles in quadrants 3 and 4, so that's 225. And it's also 315. And that's our solution. Okay. Oh, sorry. 0 to 2 pi would be in radians, so we're going to want the radian values on that. So this is going to be 7 pi over 4. This one would be 5 pi over 4. Okay, make sure we're in the right units. All right, your turn, 79. All right, last one. This is an application from calculus. We're going to use this to find the derivative of sine. Okay, so if you take calculus next year, you'll be working on this. We want to verify that this ends up equaling this. All right, so we're going to split this up using our sum for sine formula. So we've got sine x cos h plus cos x sine h, and then still on top here we have this minus sine x, and this is all over h. All right, I'm going to put these two terms together because they both have sine x's in them. So I'm just going to rewrite this real quick. Sine x cos h minus sine x plus cos x sine h all over h. And notice here, if we take these two, we can pull a sine x out front. So we'd have sine x cos h minus 1 plus cos x sine h all over h. Okay? And so then, if we look at this, we're going to start to match it up with these two pieces. So if we look at this first piece, the cos x times sine h all over h, do we have that? That's this piece divided by h. So we can rewrite this. Cos x sine h over h. And then do we have the second part? We almost have it, but it's not a minus. So right now we have plus sine x cos h minus 1 all over h, which is very close, but this is a minus and this is a plus. But notice here that this is switched around. So anytime you want to switch a positive to a negative, we switch the terms around. So that's exactly what we're going to do. This becomes a minus, and we switch the order of our terms, and our job here is done. We have proved that they are equal to each other. All right, so last one. See if you can do 105. See if you can prove that this turns into this. All right, good luck. Any questions, make sure you're asking in class. We will go over anything you need. See you then. Good luck.